Question 35. A photon of wavelength lambda naught scatters off an electron at rest. The shift in photon wavelength is lambda naught, delta lambda, and what is the kinetic energy of the scattered electron? So this is Compton scattering, and we have two formulas, right? We have the lambda f minus, let's keep this in the corner actually, lambda f minus lambda initial is equal to delta lambda is equal to h 1 minus cos theta. And so in this case, we don't know the angle of scattering. And they have not included the mass in their calculation, in their final answers. So ideally, we should not be using this formula. Another thing to note is they told us the electron starts at rest and they're asking for kinetic energy. So that means we must use the energy formula, and that is HF. But we're only given in terms of wavelength, so let's use wavelength. And now what we can do is find the initial and final energies. First, let's draw a diagram. So we have a with small wavelengths, we have a photon hitting a electron at rest, right? So initially, photon has all kinetic energy, EK initial. That's right, KE initial. Then let's draw a line before, after, and we have this longer wavelength scattered photon and a scattered electron. And so now energy is lost to the electron, right? So now we have kinetic energy of electron, kinetic energy final of the photon. So what we can do is find both energies of the final and initial of the photon using this formula. And so we have E initial, or let's just do E naught is equal to HC lambda naught, right? And then we have E final is equal to HC. And this is an important thing, right? Plus lambda naught. Because what you must know for Compton scattering is wavelength always increases. Wavelength of the photon increases. And this is because the energy of the photon is lost to the electron, and therefore wavelength increases. And you can tell that from that formula itself here, as energy decreases, energy is lost, therefore wavelength must increase, right? And we can maybe delete this. And so that's where this comes from. And so our E electron must be E final of the photon minus E naught, which is equal to E naught, E initial. That is the total kinetic energy minus the E final. And we get H C lambda minus HC delta lambda plus lambda naught. And that is D. That's our answer.